Hello, and welcome to tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at connecting sports with mathematics. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists tonight, Kara Lehman and Tracy Wingert. Kara has been teaching mathematics at the high school level for 25 years. She currently teaches Algebra 2 and Calculus and enjoys every opportunity to incorporate technology into her lesson plans. Also, a track and cross-country coach, Kara has a special interest in applying mathematics to sports. She enjoys working with teachers to explore ways technology can help by deeper conceptual understanding for students. Kara, thanks so much for being with us.
My pleasure. I have a little bit of adrenaline going already, considering I'm in the middle of a tornado watch.
I hope it stays as a watch. And Tracy holds a bachelor's in mathematics from Iowa State University and a master's in instructional technology from Morningside College. He was a mathematics teacher for 19 years at both the middle and high school levels. He is in his third year of a 6 to 12 technology instructional coach position for the Lamaros Community School District. He's been a T-Cube instructor since 2008, and Tracy enjoys helping teachers achieve their technology goals in their classrooms. Thanks so much for being with us, Tracy.
Thank you for having me. I'm very excited to be here tonight, and it's always a pleasure when I get to work with Kara.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to Tracy or Kara using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages tonight. We hope you don't have any audio issues, but in the event that you do, if you can find the participant window, which is in the upper right-hand corner of that slide icon right there, in that window, in the lower left, you'll see a very small phone icon. If you have any audio issues, feel free to click on that phone icon. That'll give you a call-in number, and you can actually use, say, a cell phone or a landline to call in, and that should correct any audio issues that you may be having. As a reminder, this session is being recorded, and we'll provide a link to the event's certificate of attendance at the conclusion of the webinar. Once the recording is available, we really hope that that's how you're going to follow along. It will really allow you to go at your own pace, and you won't be necessarily trying to follow along with your handheld or your software as Tracy and Kara are trying to present the material tonight. So sit back, relax, and enjoy. Kara's going to discuss our agenda.
Okay, tonight we are going to show you several different examples from sports. We are going to describe a project that I've done with my students. But in addition to that, we're going to go through several examples of how you can bring live pictures into your TI-Nspire to just motivate the kids to see some modeling in their everyday world. And so some of the examples are going to be things that we use just as examples with the students. The shot put that we're going to start with, for example. And basketball I've used in both as an example, but the particular one we're going to share with you tonight, the next four, basketball, Sour Patch Kids. I'm sure you're wondering how that relates to sports already. Tennis, and of course bottle flipping is a sport everywhere. So I'm going to share with you some projects that my students did and different approaches to the modeling that they had. In addition, we would hope that you will pick up on a lot of the mathematical practice standards that come into play during these activities. Also, we are going to share with you, oh, sure, Mike, do you want to talk about the online resources?
Sure. I was just going to mention that at the conclusion, we'll talk through some online resources that are available, as well as stick around at the end. We'll be giving away a complimentary registration for the T-Cubed International Conference, which is coming up really soon in March. Thanks, Kara. And Tracy is going to discuss our expected outcomes.
So when this is over tonight, we're hoping that you can look at the activities that are being shared with you and the angle that we're looking at those, the lens, so to speak, that we're looking at them through, and see how we're trying to bring mathematics to life for kids, connecting things that they're interested in, for instance, sports with TI technology, or bottle flipping, or Sour Patch Kids. We're trying to showcase things that are applicable to Algebra 1 and or Algebra 2 classrooms. And then again, as Mike indicated, the resources that Kara and I share with you tonight, they will be immediately available to you at the end of this webinar. And one thing I do hope you notice throughout the course of the evening is Kara's students several times are regularly addressing several of the math practices. You're going to notice her students creating arguments and critiquing others. You're going to notice her students modeling with mathematics. You're going to notice them using appropriate tools. And hopefully by the end of her lessons, her students are attending to precision. And so this is something I hope you notice kind of a theme recurring over and over as we talk through these different examples tonight.
Thanks so much, Tracy. Kara, it's all yours.
Great. One of the things, too, as Tracy mentioned all the practices, I think if you do get a chance to focus on modeling, I think all the other practices just come along with it. A lot of times the practices that we're concerned about don't necessarily, aren't sometimes the ones that we're thinking about ahead of time, and especially when you concentrate on modeling. So let's just get started. The first thing I want to share with you is a video. Can you see my screen, first of all? Mike, did I do that right?
Not just yet. So
okay.
Just make sure you do the share at the very top.
Right. Are we good
great,
now?
Kara.
Okay.
There you go.
Thank you. So the first thing we want to do is just show you a video that we took at track practice. So we've had some unseasonably warm weather in Central Illinois lately and have had actually a chance in this indoor track season, I'm a track coach, to get outside in the shot put rings outside. Shot put is generally concentrated on in the beginning of the track season because it's the only throwing that we do indoor. So these are some students of mine that we have in this video. I'm just going to go ahead and play it for you and ask you to just focus on some of the mathematical questions that you might be thinking watching these students. And I actually am going to concentrate mostly on the student in the blue. And I'm going to play it for you a couple times. First, I'll play it in full speed. It's very short. And then I'm going to replay it, and there's this option here to play it at 1/8 speed, and I'll show you the 1/8 speed. So I don't know if we have any track coaches out there, particularly throws coaches, but I'll just tell you now, I am a track coach, but I'm a distance coach, so coaching the throw is not my thing. However, the mathematics that's happening here in the throws I just can't ignore. So I will be giving you some tips and things that my head coach also is a throws coach, and he's kind of given me some pointers of things that he wants to happen and things that he's told this particular student are not happening, or maybe some things that are happening. And we're kind of curious if any of you can pick up some of those things. So just one last time here in 1/8 speed. Okay, so picture for you to think about.
Now, I am not a track guy, Kara. And so you have had to drag me along into this world, almost kicking and screaming. And so for the people out there at home watching at their computers, I'd like you to look at this picture, and I'm going to ask you the exact question that Kara asked me. What is mathematically important about this picture? So go ahead and look at the picture for a minute, and go ahead into that chat window and type 1 or 2 things that you think might be mathematically important. And be sure to hit send. So we've got some individuals talking about path of a parabola. We've got trajectory. We've got the angle of the release.
All very good and important.
Kara, we've got some people noticing the release height or the release point.
Ah, nice. Yeah.
And then we've got some people dragging some physics into this.
Oh, okay. Well, it's time to tell them then, Tracy.
Yeah.
So we're math teachers, and as embarrassing as it is, I do always have to check physics questions with our physics teacher when I'm uncertain about things. So we aren't going to address a lot of the physics questions, but I think you might have some interesting things to offer along the way if you're a science person. I do want to tell you, Tracy, one of the things that you hadn't noticed in this picture was the ring. Can you see my mouse?
Yes, I can.
Okay, so the ring is down here. His foot is currently at the very tip of the ring. And one of the coaching tips that our head coach said is that on a good release, this ball would actually fall straight down out of the ring. And so, you know, we're wondering maybe if that happened in the video.
Kara, can we take another look at the video and see, and maybe we can stop it and see if that young man would have dropped it into the ring or not?
Sure. That may or may not be important, but it is something that you had mentioned you hadn't noticed. I'm going to slow it down here again.
So when he releases, so what do you think out there on the internet? Would that ball have dropped where Kara indicated you'd like it to drop if it's a good throw? Would it have dropped out here? Boy, oh, this young man is getting not a lot of love out there. Pretty resounding no.
He signed up for this. He said he was totally fine with us using his throw. So
he's getting a lot of no's out there, Kara.
Uh-oh. All right. So in addition to a lot happening in this picture with the release of the shot put, there's also some interesting things I think somebody has already mentioned, Tracy, about this picture. Just some things to think about.
And so this image here just hammers this point home to me, and I think it's fabulous. So I can see if his arm was to extend at that 45-degree angle when he releases it, here it's going to maximize out his throw. And what happens?
You're looking at this line here, and then going with this parabola here. Or is it a parabola?
It's a great question, Kara.
Somebody mentioned that it was a parabola. That's why I use that word. But.
And I'm a visual learner personally, and so to see what happens if this young man, instead of throwing at that 45-degree angle, if he throws at that 30-degree angle, what's the consequence of that?
Well, I've heard our coach say, hey, that throw was really flat. So maybe he's talking about this kind of throw. What he did say is that he really wishes that he could explain to them, and he does these videos and he shows them in slow motion their throws, but still, do they really understand what he means by flat? And what does an ideal throw look like compared to the one that you've done? So that's where he said, you can really model this on your calculator? So, challenge accepted.
So let's make this more visual for this young man.
Okay. So we're going to pull up TI-Nspire, and I'm just going to go through a couple of basic things. If you haven't had a chance to insert images into the TI-Nspire before, it's very simple. I have taken a couple of screenshots from the video, and I've also photoshopped them a little bit so that we have different screenshots all showing up in the same image. That was about a 30-second job on an app that I have for superimposing pictures. Basically, you pull up one picture, pull the second one up, and then erase everything in the second picture that you don't want. So I'm going to pull up a picture right now that shows that shot put of the young man in the blue where he has released the shot put. So on the TI-Nspire, you're just going to come up here to the Insert, same place you go when you want to insert a new page to your document. But down here you have this choice of image. So I'm going to pull up the image of his shot put and just throw it in here. And I guess my first thought is, so I have done this I took 4 images. I just couldn't erase his arm. I thought it was just too nice to leave that in there. But this position right here is obviously after the release. So does this remind you of anything?
Kara, that looks an awful lot like that graphic you showed moments ago about that perfect idea of how to release that shot put at that 45-degree angle.
Somebody had mentioned, you said, on a trajectory. What do you think we should do with this?
Well, if I want this young man to see it visually, I think I need to maybe put a line on there so he can see what this path looks like.
Okay. So simple enough. So if I want to add a line, I'm just going to actually put a line on here, pretty general, and just start dragging it around. What do you want me to do with this? You
well,
want some ideas?
Let's take a look at the path of that shot put. Let's see if we can get a line that represents the path that shot put is following as it leaves his starting point to the end of his hand there.
Okay, so just dragging it. We can either translate it or we can rotate it. You want me to just kind of see, whoops, I didn't mean to do that.
And that's what happens in our classrooms anyway.
Well, I think I might pull it down a little first. Try this. Feel free to give me any pointers, Tracy, along the way.
Oh, that looks fantastic.
Look pretty good.
So as I'm looking at that, as a math teacher, I love the equation that's been generated. But what I'd like to know is, what does that equation mean about this young man's throw? That might be significant. It might tell me something. And so I'm going to pose that to our audience is, what can that equation tell us about this young man's throw? Go ahead and share your ideas and press send.
I just want to add, Tracy, that if you're going to share your ideas, it's really great to share those in the chat window. The Q&A window is really great if you have any questions, but chat window is really great for those comments. Thanks so much.
Thank you, Mike.
So what are we getting, Tracy?
Well, we're seeing that we've got a slope of 0.6 or a slope of 3/5, depending on how you like it.
Okay.
We've got an indication from someone out there that says it's less than 45 degrees.
Okay. So if we're talking about using this in Algebra 1 or Algebra 2, how do I know it's less than 45 degrees?
And so if it's going to have a 45-degree angle when he throws that, I think that's probably going to have a slope of 1. And so those out there in the chat window, what can we do to visually show this young man what his throw should look like? What can we do this picture visually to help him see immediately, this is what you'd like it to look like? And go ahead and share.
Probably a lot of different ways you can do that.
Well, we've got some quick replies. We've got a line with a slope of 1. We could change your line, it says, and give it a slope of 1. We could graph another line with a slope of 1 and start it at his elbow.
Okay.
So what do you think, Kara, if we throw a second line on there?
Okay.
Let's see what that looks like.
And just give it a slope of 1?
And let's give it a slope of 1.
Okay. So then when I move this one, you don't want me to rotate it at all. You just want me to translate it. So I'm going to be looking for the...
Sure.
So just the crosshairs here in the middle is just going to translate it, whereas the rotating is going to happen when I get the little arrows.
There we go.
Okay. And where would you like me to put this?
Well,
here? Or did we want that 45 to happen up here? What do we think?
Well, what do you think out there in the chat window? Where should we put that at? Well, we've got some that want it at his elbow. We've got some that want it at the release point.
Should I ask which elbow? Because that was kind of fun.
He does have 3 elbows.
He does have 3 elbows. 4, really, actually. Okay, so we want it here.
Starting to see some indications that maybe from the point of release.
Okay, so here. Do we want to go back and look at any of those other pictures?
Well, Carrie, do you happen to have that handy?
Yeah, I do. So this one, it looks like we're looking at 45 degrees here. So I think that's what you're meaning by point of release, correct?
That is correct, Kara.
Okay. So I think this particular picture is probably enough to let him know that his throw was a little flat. Does that make sense?
It sure does. And hopefully you can quickly see what he needs to do to repair that.
Mm-hmm. Well, I would definitely think that our coach would be able to talk about the idea of it being flat and with a little more proof, if you will, that it is not necessarily what he means when he says the perfect release. So we talked a little bit about bringing in a picture before the release. I want to just share with you real quickly. So I'm going to bring in one more image here. And this time it's basically the position that our coach calls the power position. So it might be interesting now, because this is basically before the other image that we were playing with up here. So this is, and can you tell how much before it was? Did you notice the scale down here? This app that I was using to stop the video and play it in slow motion is free and easy to use to take the screenshots from. And this timeline down here says 3.30, but when I'm over here, oh, I thought I was covered up there, 3.23. So it's pretty precise.
That's a short amount of time.
Yeah, this is the position he was in before that. And you can see I tried to superimpose like 2 pictures here, so possibly these might be on different planes, whereas all of these probably are in the same plane. So at any rate, what could we do with this to talk about maybe what's wrong with his release is his power position here? Can you think of any ideas of what we might want to do with this?
You know, and Kara, I'm looking in the chat window a little bit here, and got a few people making a few comments, and maybe the starting height address, the point of release, where the y-intercept of your parabola for a time equals 0 makes sense there. Maybe lower his elbow at the position.
Okay. So is there a way to show him that his power position might be the problem?
Well, if we go back and look at that line that you put in there, Kara, that red line earlier?
Okay, so you want me to do that from this page?
It sure looks to me like maybe he should be starting lower.
Okay. So possibly if you're new to Nspire, or I just want to show you that this is all within one problem here. I've added these pages, these graph pages, all within one problem. So if I'm on page 2, my page 2 is actually interacting with page 1. So if I just ask the computer to graph, do you want me to graph both of them or just that perfect one here?
The visual guy is happy with the perfect one.
Okay, so lots to maybe look at here in terms of where he needs to be by the end of that. How much time did we have?
Boy, 0.07
0.07 seconds to get in a better position. I don't know if it's going to happen. So at any rate, our throws coach was pretty excited about this idea of bringing this into the classroom and showing students and helping them see the mathematics behind what a flat throw looks like. But even better, I think we can actually take some images that involve the actual throw itself. So this is not quite as zoomed in on the video. You see it's towards the end of the video as well. And I've already brought this into the Nspire, but I do want to ask you to be thinking about this.
And so as you look at this image here, those of you in the chat room, we'd like to know, based on what you've seen about this young man's throw, and you have a few to look at to get the idea started in your head, what you've seen earlier and the equations that were generated, did he throw the shot put short or did he throw it long? Which one did he do? Go ahead and put your vote in and hit send.
So we're talking about these two different shot puts that are actually in the sand over here.
Boy, Kara, it's kind of an overwhelming opinion of short.
Well, that's because you're math teachers.
That's right.
The kids don't know. Plus, I played the video about 5 times. So if you only show them once, it's a little bit harder to tell. But this does bring us into kind of a good segue into the project that I assign my students. So using this as an example, I do this project that I'm going to share with you tonight in Algebra 2, but I can see lots of different places it could be used. And I have done it during my systems unit. So my goal isn't that they necessarily use quadratic regression on the calculator to come up with an equation for what they're modeling. I would prefer that they think about the current chapter that we're studying, and the unit does fall in my Algebra 2 system. Systems falls after quadratics, so they've studied quadratics, and then we're doing all kinds of systems, 3x3 systems and nonlinear systems. So, go ahead.
Kara, we've had an interesting question pop up, and one teacher's wondering if there would be a way to use the Nspire to find the coordinates of that shot put at various positions. So would it be possible to throw a point on an image and get those coordinates? Is that something that the TI-Nspire can do? Absolutely.
And so I am going to share that later on, because that is definitely one of the strategies that some of my students used. And you're starting to think very precisely about where we can model the parabola. Or again, we're just assuming this is a parabola, right? So Tracy, you're a tennis coach, and we've talked back and forth about whether your tennis serves are actually parabolas, right?
Yes, we have. And you know, I'm looking at this, and why you wouldn't want to have a racket out there, I don't understand.
Why you just wouldn't want to run away from this is what I don't understand. Yeah, so neither one of us are throw coaches, but I think that I have learned a lot about throwing the shot put just from studying these images myself. So, I like the idea of putting points associated with the places where we see the shot put, but I think let's save that for later. And maybe just, I want to show a couple other things here about the Nspire that might not be totally obvious. And I am a calculus teacher, so I also have some ideas about this from a calculus perspective a little bit. And I would just want to go ahead and start with the model we've been doing is just throw a parabola on here, see if it looks like it works. So we're just going to start this time with x squared. And
Kara, is that something your students would do, is they would just throw that parabola on initially, not realizing that, whoops, I need to have a negative?
Oh, absolutely. Yes, for sure. And I find that, I mean, this is probably something that a lot of people do, just putting images in the background and trying to model what's in the image with a curve. And the beauty of the Nspire is just being able to grab whatever model you think is appropriate. Of course, there are only a select few that it actually will transform like this, but there's enough that we can learn a lot from just moving it.
And I agree, Kara, that's one of the fantastic things. I did not personally grow up in a world of click and drag, but our students don't know a world without it.
Very true. Yeah, so this would be a lot of times their first inclination is to just throw this on here and be done, right? So I'm going to try to move it. So I don't know if it's possible to see. I got a shot put here, and I got one here. I've got one over here, and then we're trying to figure out, is it this one here or this one over here? And it's probably a little more obvious that everybody in this chat window seems to know what we were going for there, right, Tracy?
I think so. I'm thinking the only person that would have voted for that long throw would have been that young man in the blue shirt.
Very true. Good point. All right. So this looks pretty good. So my goal would be, is there another way without using these previous two images to show him from this picture? Because he may not even believe this whole business up here that it's supposed to be the red line versus the blue line. You know, he may not believe that that's true still from here because he doesn't see it land. But here we can see clearly where it lands. So we still may want to teach him something from this about how far it's going to go and maybe get him to believe more in this idea here that the blue line is a flat a release. So what I was thinking maybe here is that we could do something with this curve, and maybe we haven't seen this feature of the Nspire before, but you can actually, using the geometry menu, what might we want to do here?
We've got a request from the chat room to maybe throw a tangent line on there.
Awesome. Okay. So this tangent line is going to hook onto my graph wherever I want it to go. So if I just click on my graph, and then click again, also very simple to do on the handheld. I can extend it a little bit. No, that's not a good idea. Let's just escape out of that one. Where do I want to be here? There we go.
That looks really good.
I have been able to grab my line and extend it, but maybe I won't try that again. But I can move this point, and that tangent line's equation is showing up again. So do you remember what our slope was before?
Let's see, was it about 0.59?
Somewhere around 0.6.
I believe so. Oh, yep, we got a bunch of people corrected me, 0.6. Thank you.
0.6, okay. All right. And then obviously this one is a little more rough because we can do a better job, don't you think, of modeling the parabola that we see? I just kind of fit the curve on there. I like the other advice that you had of actually putting some points where the shot put was.
Absolutely.
But it's just kind of neat to see and let him see that this 0.6 here is actually going to actually land here. And if he could imagine a parabola coming off of a tangent line that had a slope of 1, would that parabola actually go longer? So, and you know, we can get picky about, is this really where it was released and that kind of thing. But again, just as a teaching tool, I think it was enough for him. So
that's a fantastic visual.
So let's get into more of the project. So this is a great example, I think, that I definitely can use as a teaching tool. I haven't used it yet in my classroom because I just took it. So this particular one was just a thought recently that I could use. I've used basketball a lot. I've had the star football kicker in my class before, and we've actually gone out and tried to measure how long his kick was going and using proportions in the image and that kind of thing, trying to actually estimate how far his kick was going. But I really like this shot put, and hopefully you guys that are in the session here can take something from it. But going on into the project, let me just share with you what I had as guidelines. So these are very basically the main idea of the project. We are going to share with you a folder that has a rubric and exactly the directions that I give my students, but these are the 4 big ideas. So we want them to video an object that's in motion through the air. And they're starting to believe that there's just a lot of things that get modeled by parabolas. So I've shown them several pictures of students. Like I said, I've used basketball and football kickers and things like that. But they're getting this idea that anything going through the air is maybe a parabola. I want them to take a screenshot in at least 3 different positions from the video. It was actually one of my students that showed me the superimposing app that is very simple to use for putting the images together. I'm sure there's lots of other ways to do it with Photoshop and things like that, but I've done this project where I'm just doing the object on 3 different pictures even. And then one of the things I wanted, there's so many times where we model parabolas from pictures in the background, but there's no necessarily motivation for knowing what the equation is. How can the equation help me to answer a question? And I think with sports, we just have a much better opportunity to care about why we're modeling this parabolic motion. And then I just ask that they show a conclusion about how the math performed in the video agree with each other. So kind of your Act 3, if you will.
And Kara, were your students successful on the very first try when they did this, or was this something that took more than one try, whether it be the video or generating their curves or fixing the image so they could see multiple points? Was it just a quick one and done, or did this take them a little bit?
Okay. Well, actually, I asked them to form their groups based on the I had people volunteer. I didn't even tell them what their project was going to be. I just said, who is going to consider themselves an expert on taking screenshots from videos?
And every kid in the class put their hands up.
There were quite a few volunteers for that. So, but then I said, are you sure you're an expert? Like, we're going to be very specific about your screenshots. We might ask you the time you took them. Can you play things in slow motion, things like that. And so I had enough students volunteer, for sure, as you can imagine, to be kind of the leaders of their groups. So they at least felt like they had somebody who was a go-to for that. And then from there, yes, I had various levels of ability to follow through. And I'm going to share some of those with you here in a second. So the first one is your obvious. Here's one of our star basketball players, and your obvious, you know, did he make the basket? We've seen this all over the place. But I can show students this picture with people they don't know in the picture, and they you know, it's kind of interesting maybe, but to have someone they know in the picture and to have two guys in this group were like, well, we got basketball. Nobody can have that because two guys in the group were on the basketball team. So they shot this at practice and pulled it into Nspire. And so their approach, I'm just going to share with you some of the different things that students did. So their approach was interesting. During that systems unit, they noticed some ways to make systems of 3x3 equations easier. One of them being that, well, gosh, if I can make this so that one of the screenshots shows the ball on the y-axis, I think I'm going to save myself some work. So these guys moved their axes down to about here. And I had an interesting discussion with them about, well, why do you only have two? Because I asked you have three. And they said, well, one of them is definitely where his hands are because he doesn't move his hands. When he shoots that ball, he waits until it goes in or doesn't go in until his hands move. So they convinced me, and this, if there's basketball coaches out there, you tell me, because I was sold that the ball was actually right here, and they wanted the ball to be on the y-axis. They thought the work would be easier.
And so did that make their job easier? Did they do a better job because they made it easier?
Well, so their next step was oftentimes we like to put on the viewing window, we like to put the grid in the background. And dot grid or line grid, matter of preference. But if we put a dot grid, it might be helpful because we're kind of trying to model where the point is where the basketball was. So this was what they did. And they just weren't willing to, they thought that because it was kind of a fuzzy image that maybe if they just rounded to the nearest integer, everything would work out okay. So their work is actually here. And so if you weren't sure what I meant by using a 3x3 system, you can see they chose the point here, 110. So they're letting ax squared plus bx plus c equals 10. So they're put in 1 for x. And then what happened here? What were they doing here?
So does anybody have any thoughts on that you could share in the chat window? Negative c equals -8. What are they doing there? What are they thinking?
So back to this picture. I haven't really played with the axes much, but they did. So here's his hand, and they were dragging these axes around to kind of make things work the way they wanted to.
Well, we've got some thoughts on that. Maybe
pretty close to what they did here.
Maybe it's a y-intercept, some think.
Mm-hmm.
Maybe subtracting the height of the ball.
Nice.
Maybe it's the initial height.
Mm-hmm. Okay, so what they were thinking definitely was the y-intercept. So putting 0 in for x, 0 squared times a plus 0 b plus c equals 8. And then they ended up starting to solve the system of equations here. They used that negative c equals -8 twice, and then their third point was up here. So what value did they plug in here, Tracy?
Kara, can you repeat that real quick? You just cut out just a little bit on me.
Sure. My question was, what point did they plug in here? Substitute for x and y here.
Well, if I go back to their picture, let's see.
And I'm just trying to recreate what they did for you here.
So I'm gonna guess that they used the basketball here, the first basketball that I can see, kind of by the tee, or they used the one up at the very top.
They used both of them. So this one, and this may not be exactly how they set up their window. I've got theirs here. So I was just trying to recreate to show you kind of how it was. But now you might be able to see a little better. They used 0, 8, and then they used 1, 10, and then over here I think this was 7, 14.
Kara, I'm a little surprised that the star of your basketball team would choose a shot for this project where he doesn't make it. That's
Well,
kind of
fun, right? Because they had to play the video in their presentation to the class. So you are spot on, Tracy, because it did. Obviously, you're right. He wanted to showcase how he could swoosh, and it did go in, but their work did not support that. But they were just so good about how they explained why things didn't work, and
Kara, if you go back to their work their student work, as I'm skimming as fast as I can, their calculations look pretty good.
Right. Yeah, and this is what they had to say about it. So our parabola did hit all of the points that we had predicted. Well, of course it did, but did not go in the basket. Our solving of the problem and the final answer are correct to fit the points we predicted, but the ball did not go in the hoop because our points were not as accurate as they could have been. So, yeah, they definitely weren't into putting points on the grid like someone had mentioned earlier as a possible way to be precise, but they were very satisfied with the results. They knew if they could have been a little more precise, it would have worked, and they were happy with that. So,
and I think that's pretty cool that they recognized this is what our problem was. Here's what could have fixed it, as opposed to you just telling them what the problem was. Right,
and that's exactly the conversation that we had during their presentation, actually, to the class. They were that confident that this is a good enough answer. We're just going to present this. So then onto our second example here, the Sour Patch Kids. So these two students, as you can see, were much more precise, and they did what our participants suggested, that they actually put points. Oh, by the way, Sour Patch throwing is a sport here for long distance runners, because this is the star of my cross country team here. But it is dead of winter, and we might have even had snow on the ground here because I signed this project right when they come back in January. So we did have some students here that thought using an x-intercept would make the project easy as well. So this is one place where the Sour Patch was in the picture. Here's another position, a third position, and then they were showing that it did go into her mouth. And this one was very similar to the basketball, so I'm not going to go through all that, although I will show you in a minute how they put these points on. And they became very concerned about being precise. And, you know, the mouth here isn't all that big, a little bit smaller real estate to play with as far as did it go in than the basketball was. And these were some conclusions these students made. And the reason I'm reading this is I don't know if there's anybody just listening to this. I've done that before with a webinar, but I don't mean to just read the slide. But they definitely noticed that when they were at a basketball game the next couple weeks later, all they could see was parabolas. So using mathematical equations to predict if a moving object will hit its target or not is something they didn't know they could do. And we definitely talked about other applications of where that would be important. Why do we care if something's going to hit a target? And then someone said in this group that they couldn't believe how much they learned regarding technology and how big of a part it played in putting the project together. So pretty positive. We had another group that tried the throwing the candy idea, also cross-country runners, and maybe it's a theme, I don't know. But they ended up having a sleepover, actually, and they were texting me because they're on my team, texting me and saying, we're still working on this. We've been working on it for 6 hours. We can't get it to work. So what they ended up deciding was their video was bad. And after 6 hours of playing with the different points, they decided to take a new video. So once they got it working, they were extremely pleased, let me tell you.
And Kara, I don't know what else you could ask for students to put 6 hours on a problem like this. I'd say that's definitely showing perseverance.
For sure. Something I didn't anticipate, that's for sure. So then, Tracy, I posed this to you the other day. Tell us about this.
Sure. And so I conned my son into coming to the tennis courts with me, and it's very uncommon in Iowa in February to not be covered in snow, but we've had some freakishly warm weather, and unfortunately we had a blizzard move in right after this. So I begged him to come out even though it was raining and serve a couple balls for me. And I put this together and had Kara's daughter quick do the photo burst for me because it was just faster to have a teenager do it. And the first question Kara asked me was, Tracy, did that go over the net? and I kind of giggled because, you know, she threw quite a few track questions at me that I wasn't equipped for. And so I just told her, just like she was one of my students, I said, well, figure it out. And so that's what we thought would be fun tonight to do with you. So we have shared this image with you, and you'll get a link to that here at the very end of the presentation. And I think Kara has even put a link up here at the top that you can use. And Kara, is that link for all the resources or just this one?
Mm-hmm. Yep, all the resources are in there.
Okay, fantastic. So what we'd like to see you do is, could you take and put a curve to that and show us visually, does that clear the net or does it not clear the net? And tweet out the results with hashtag STEM and sports, hashtag TCubeLearns. And we'd really like it if you've got a neat idea like this that you do, whether it be tossing Sour Patch Kids, or maybe it's a basketball, or maybe it's the shot put or the tennis. Share your ideas using those same hashtags on Twitter, and let's see if we can kind of keep this sharing of ideas going well past tonight's 1-hour webinar.
So quickly, I want to share the idea that somebody in the group had about putting a point on. Very simple, putting a point on the grid. You can either do it on the grid or just right here on your object. If you put a point on, you can also escape out of here and just hover over it, and with a right click, you can ask it for its coordinates. And these coordinates here, you can get a little more precise if you want to. Just hover and change the attributes to make it however precise you want to be. And then you can see kind of how you can use a little more precision and using a system approach to get some points to use. Last, I want to share with you a bottle flipping project real quick. This person also decided to use the approach of putting some points on. And these are the points that they chose in the middle of their bottle flipping activity. But their approach was actually a little different. And they stored these coordinates into variables, made a spreadsheet, and then made a scatter plot so they could see it without the image in the back. And clearly, they were quite alarmed at the fact that this didn't look very parabolic at all. And they did try several different things. They weren't convinced. There's got to be a parabola that fits through here. And just real quick, at the end of his presentation to the class, he said this: during this project, I learned that bottle flipping has a lot more math involved in it than I originally thought. It turns out that it does not follow a parabola unless tracked by a center of mass, which is constantly changing due to the water sloshing inside of the bottle. And he told us, he said, turns out I'm not the only one that studied bottle flipping. And this kid is not in physics yet, so, you know, it just really piqued his interest on what was really going on here.
Kara, could you do me one favor real quick? Could you put that tennis slide back up just for a moment?
Sure.
We've got one or two people that were trying to get that URL.
Sure.
Kara, do you happen to remember if that's an L in front of the 5?
I do believe.
Also, in case anyone can't feverishly copy this down quickly, you're going to get a link to these documents that everyone's using tonight in a few minutes here. So have no fear if you don't have a pen and paper ready. It's okay.
And all these TNS files are also in that folder. You can see kind of some finished products if you wanted to use any of these with your students. Bad examples, good examples, etc. So lastly, we wanted to just share with you quickly some of the things that we think students have taken from this project, that some we did not anticipate at all. And for sure, we had students doing the modeling with different approaches in the Nspire. which was really neat to see them coming up with their own ideas. The value precision came out. The perseverance, having a sleepover to do math, what's that all about? And satisfaction for sure of a job well done. I think I did get a text early the next morning about the fact that they had finally figured it out. And this was definitely true. Things that start out as math problems become science problems, because I find myself in our physics teacher's room asking her questions too.
And Kara, I think maybe a nice way to wrap up tonight is I'm looking at one of the comments in the chat room. Bad examples can sometimes be just as enlightening as those that work exactly as expected.
Very true. And often bad examples when they have authentically taken the data themselves and they have to figure out what it is that was the problem. Was it them or was it the data? So definitely a lot to learn there.
I think it's a great project.
Well, thank you, Tracy.
Mike, we're going to turn it back to you.
Sounds great. As we begin concluding things tonight, if you have any last-minute questions for Kara or Tracy, please try to get those asked. I know they'll do their best to get those questions answered. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online events, so we really hope you share your thoughts in the post-webinar survey. Before we start tonight, both Kara, Tracy, and I were talking about the upcoming T-Cubed International Conference and what time we were arriving for that. So all three of us are going to be there, and I know all three of us are probably looking forward to a lot of the sessions and meeting up with colleagues and friends that we haven't seen in a little while. So I really hope that you'll be planning on attending the T-Cubed International Conference. And as I mentioned earlier in the agenda, tonight we're giving away to one lucky winner a T-Cubed International Conference registration. And tonight's lucky winner is Denise De La Toro. I think I pronounced that right. So Denise, congratulations. And we'll be in touch over email in the next couple of days to give you a little more information. But we hope to see Denise as well as everyone else at the T-Cubed International Conference coming up very soon in early March, March 10th. So Tracy and Kara gave you a great challenge tonight. Stay connected, take their challenge, and use those hashtags on Twitter. I know that we'll all be looking forward to your thoughts and your comments. I'm really excited because we haven't done something like that in the past. This is kind of a first for us, and I look forward to talking to Kara and Tracy in the coming days and the coming weeks here to see what you guys have come up with. So please feel free to stay connected with us. To receive a certificate of attendance, go ahead and click the link. Nope, not that one, sorry. Try this one more time. Click. There we go. Click the link in the chat window. I also listed a link for the documents as promised that were used tonight, and that includes, as Kara mentioned, the TI-Nspire, the TNS files, Tracy and Kara's PowerPoint, as well as my PowerPoint. They'll all be listed there. If you're watching this on demand, go ahead and copy that link into your browser to receive your certificate for tonight. If you're in the need of any post-webinar follow-up, give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. Thanks so much, Kara and Tracy, for everything you shared tonight. It really is exciting stuff to see.
Thank you to everybody who took the time out of their evening to spend it with us. And again, if you're in Chicago, stop by and say hi to us.
Thanks a lot, Mike.
And Kara, I'm really glad that you're still with us, and hopefully the tornado dissipated or passed you over safely?
It does look like we're out in the clear now.
That's great.
Fantastic.
Thanks again, everyone. I hope to see you back online real soon. Have a great night.